Okay, why don't we get started? First of all, good afternoon, everyone, and thank you very much for joining us at the University of Toronto's Rotman School of Management for this special collaborative hybrid seminar, which is co-presented by the Institute for the History and Philosophy of Science and Technology and the Schwartz-Reisman Institute for Technology and Society. My name is Karina Gold. I'm an assistant professor at the Institute for the History and Philosophy of Science and Technology. I'm also a research lead at the Schwartz-Reisman Institute. So this is a wonderful occasion for me to bring together my kind of two separate communities that I have at the university, both of which I think are really special and have something interesting to contribute to the discussion of how technology, especially AI, is impacting society. And I'm especially excited to moderate today's seminar featuring our guest speaker, Catherine Stinson, who I'll introduce properly in just a minute. But before we do that, I want to begin by taking a moment to acknowledge the very special land on which the University of Toronto operates. And for thousands of years, Toronto has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is still home to many Indigenous people from across Turtle Island. And we're grateful to have the opportunity to live and work on this land, which I cherish. Next, a few logistics before we begin. So with the permission of our speaker, this session is being recorded, and the presentation will run for about 30 minutes, followed by a 1-hour Q&A in which our speaker will engage with the audience. During the Q&A portion of the event, for those in the room with us, we ask that you please raise your hand to ask a question and speak clearly so your contribution is captured for the participants online. No microphone is required because this room is configured to pick up audio throughout the space. With that in mind, please refrain from any side conversations because it will pick those up as well, and that will make it difficult for people online to enjoy. So we will have time afterwards for more conversation, and we welcome you to stick around to enjoy some refreshments and chat a little longer with our guests. For participants joining us online, we ask that you please type your question into the chat. You can do that throughout the talk as well if you'd like, and then at the end, we'll moderate and we'll relay these questions to the speaker. So without further ado, I'd like to introduce our speaker for today's session, Catherine Stinson. Catherine Stinson is the Queen's National Scholar in the Philosophical Implications of Artificial Intelligence and an assistant professor in computing and philosophy at Queen's University. Catherine's research and publications span a range of topics, including psychiatric classification, explanation in artificial neural networks, health data privacy, and critiques of eugenic technologies. Their previous roles include postdoctoral positions at the Max Planck Institute for Biological Cybernetics and the Lieberman Center for the Future of Intelligence at the University of Cambridge, as well as a senior policy associate role at the University of Toronto MOA Center. Actually, Catherine and I met when we were both postdocs at Cambridge at the time, and we both fled the UK during the start of the pandemic, only to find ourselves together again in Toronto. So with that said, Catherine's experience and training is much richer than mine, and they're trained in both machine learning and philosophy of science with experience in policy and visual art. Catherine offers a multifaceted perspective on AI. At their Ethics and Technology Lab at Queen's University, Catherine leads research that includes methodological analysis of AI, sociological studies of AI as a discipline, empirical investigations in ethical AI, technical support for data justice initiatives, and collaborations with artists. We're really excited to have Catherine with us today and are very much looking forward to their presentation entitled Artificial Intelligence, Benchmarks, and Degenerating Research. Without further ado, Catherine, the floor is yours, and please join me in welcoming her.
Thank you for technical stuff for a second. I hope I can live up to the hype of that very kind introduction. Part of what I'm going to be talking about is hype in AI and how it can be. Jump right in. In June 2020, the inventor of deep learning and head of AI at Meta, Yann LeCun, had an extended conflict on Twitter with Timothy Gebru, who at the time was the co-leader of the ethical AI team at Google, and also the co-founder of Black. And the disagreement started over how to interpret this image, which is showing an error in an image resampling model. So on the left, there's a low resolution picture of what's recognizably Barack Obama. And when it was upsampled into a higher resolution picture, it turned into a picture of a white man. And so it seemed like nearly everyone working in AI or in AI ethics was sort of either like in the fray of this Twitter battle or kind of like sitting on the sidelines watching it happen, myself included. And some of the things that people were asking were like, was this racism or just a technical glitch? Did the problem originate in a faulty data set or in the people who built the technology? Here's a little bit of where the controversy began on Twitter. Could it have been the algorithm itself that was at fault? Is it possible for an algorithm to be biased? Was Gebru being too emotional? Was LeCun being too dismissive? And so on. And as a media report about the controversy said, others from the AI and activist communities joined the fray with far too many simply attacking either Gebru. And then later the same year, the debate was reignited when Gebru was ousted from Google for pushing back against being asked to retract this paper or remove her name and some of the other Google employees' names from it. And this is sort of now a famous paper that at the time had been accepted at FACT, one of the main AI ethics conferences. She pushed back, got kicked out, and all the controversies erupted again. And this paper critiques the practice of building massive, uncurated data sets, building ever bigger models, and measuring success based on benchmark leaderboards at the expense of other goals. This paper focuses on language models, but these points generalize to other areas of AI as well. As an article in Wired at the time asked, can big tech take criticism from within? Given the controversy that was raised and the kinds of reactions that people were having to this criticism, it seemed like maybe the answer is no. That's not to say that everybody in AI is hostile to criticism. There were many people in AI who were calling out LeCun or calling out Google for these things, but it still seems fair to say that AI is often dismissive of its critics. And that's a problem because critique is widely recognized to be essential to progress in science, at least by historians and philosophers of science, at least as far back as Popper, as interpreted here by Lakatos. I'm going to read the quote. In Popper's view, virtue lies not in caution and avoiding errors, but in ruthlessness and eliminating them. Intellectual honesty then consists not in trying to entrench or establish one's position. And then later on the same page, while according to Kuhn, criticism in normal times is an criticism of the dominant theory are only allowed in the rare moments of crisis. This last Kuhnian thesis has been widely criticized. So if I'm right that AI is particularly hostile to criticism, it seems like maybe AI is kind of stuck in a Kuhnian worldview, afraid that criticism is going to sort of bring on a paradigm shift rather than seeing criticism as a potential tool for improving the science and improving and strengthening the current paradigm. And we can take things one step further. This is from Paul Thagard's paper. I had the title up there, but the PowerPoint got messed up. AI's tendency to dismiss its critics might even put it in danger of becoming a degenerating research program or being labeled as pseudoscientific. If you look at Thagard's second criterion for a discipline being pseudoscientific, he says the community of practitioners makes little attempt to develop a theory towards solutions of the problems meaning criticism. There's no concern for attempts to evaluate the theory in relation to others and is selective in considering confirmations and disconfirmations. And then if we look at some of the most recent work on scientific progress, the same kind of thing is still being said. A long list of luminaries, including Merton, Popper, and Longino, have emphasized the importance of organized skepticism about and criticism of scientific work and its results. So this is a pretty uncontroversial view in So this essential role of criticism in science is sort of maintained across this long history. And yet aversion to criticism has been around for a long time in AI. And it seems to be connected to this sort of boom and bust cycle of AI winters that are said to have happened twice already. And maybe there's another winter coming. And the dates of this sort of vary depending on which graphic you look at and who you ask. But the sort of general narrative that there have been these two winters is a pretty common narrative. The fear of the next AI winter began around the mid-1980s when the field's popularity and funding was on the rise after a dip in the 70s. So in the 70s, DARPA, which had been funding several AI initiatives in the late 60s, pulled its funding, and that meant labs had to close, some people lost their jobs and had to change fields. And why that happened, like some people blame Minsky and Papert's book Perceptrons, which critiqued connections to AI. Other people blame symbolist AI projects that sort of failed to live up to the exaggerated promises that they'd made. So one popular theory blames criticism for the first winter. The other popular theory blames lack of progress and living up to the hype. So there's sort of two possible reasons on the table for why that first winter happened. And then after this sort of alarm was raised, the second winter quickly followed. So fear of the winter seemed to be confirmed. So here's just kind of a schematic of the popular narrative that there's this cycle that happens where too much hype about AI causes disappointment when reality doesn't match up with the promises made. That brings on criticism internally, and then that turns into external criticism in the form of bad press. And then when there's bad press, that leads to loss of funding. And when you lose funding, that leads to research stagnation. And so then you've got an AI winter, and then eventually it sort of its popularity, you have to climb back up to the hype stage. So avoiding hype would seem like an obviously wise strategy here for how to avoid this cycle from happening. And that is often advised, but in the current moment, it's sort of too late for that. We're already in a moment of hype. So there seems to be an understanding that criticism should only be made in hushed tones, so that the money doesn't dry up. And in particular, the danger, as far as I understand, seems to lie in the criticism going from internal to external. The point when the press gets too excited about disappointment in AI, that's where we're worried that the money's going to disappear. Okay, so critique needs to be communicated only among insiders and quietly is sort of the sense that I get. And that means that who counts as an insider matters a lot. And we'll come back to this. But my suggestion today is that there could be an alternative narrative here. So it could be that it's the hushing of criticism that brings on research stagnation, and then research stagnation, quite fairly, might lead to loss of funding. So I'm going to argue for this indirectly with a case study from AI showing how taking criticism seriously as a guide to where the science needs improvement and further development leads to what looks like a progressive scientific research program. So I'll be offering kind of a Lakatshian picture to counteract the Kuhnian AI winter. Here's the case study. It starts with the first really big benchmark data set for AI, ImageNet. ImageNet contains over 1 million images scraped from the internet and then labeled by Amazon Mechanical Turk workers with a word or two describing the contents. And this data set was, as they often are, tied to a competition where a bunch of labs would submit models that they've trained on to perform well on the 80% of the data set that was released publicly for the competition, and then they're competing to do best on the 20% of the data set that was held back until the competition. And for ImageNet, performing best means accuracy on choosing labels for these images, them matching up with the labels that they've been given by the labels. And the sort of big event was that in 2012, the ImageNet competition was won for the first time by a neural network-based model from the University of Toronto. So these are the guesses that AlexNet, the winner in 2012, made for these images. And this win by a deep neural network was arguably the event that kind of kicked off the current hype cycle for AI. Deep learning suddenly was doing impressive things. So deep neural networks can now do this image recognition task better than humans, which is kind of odd because humans took these pictures of things that are of interest to humans and humans labeled them using a human language. So it's odd that a machine could do better than humans at this thing that's kind of like definitively a human activity. But what that means is that they're better at matching the sort of sometimes idiosyncratic labels in the ImageNet data set than the average human. But you might notice that there's some ambiguity in these labels. So if you look at the picture that's labeled cherry, there's also a Dalmatian salivating behind the cherries. So answering Dalmatian or dog or fruit, or there's lots of other things that could be reasonable labels here. And the red car is labeled as grill, a part of the car that, maybe not every human knows the name of. So accurately capturing, object recognition in general, like that's sort of an overblown claim to make of, machines doing better at this particular task than humans. Real world object recognition is context sensitive, culturally specific, open to multiple interpretations, and especially for value laden categories, there can be lots of other factors weighing in. So it might not even be possible to design a static benchmark that could take all of this into account. And to be fair, ImageNet was probably not ever intended to be used in that way. So calling it a benchmark for object recognition in general is kind of an overblown claim, and treating it as a success when machines are better at this than humans in that area of object recognition is kind of like too big a claim. But this genuinely big leap in image recognition was followed by a parade of other successes by deep neural networks. Machine translation became useful suddenly. AlphaGo defeated Lee Sedol. Autonomous vehicles started to only occasionally run over pedestrians and so on. So there's all these success cases that follow. And this has inspired optimism that maybe artificial general intelligence is just around the corner. So you get posts like this. So this is sort of a skeptical person, an AI researcher from 2019. Google revealed a system that could recognize cats in YouTube videos, and soon after came a wave of deep neural network-based classification systems. Everybody was saying, wow, this is amazing. Computers are finally able to understand the world. So hype cycle started. Soon people were making wildly overblown claims, like the computers are finally able to understand. When really they can, find cats in pictures. But at the same time, a bunch of embarrassing errors started cropping up, including some that were not just factually incorrect like this one, but ones that reveal potential problems with using these tools for real world purposes. And then even more worryingly, errors that could have unpleasant ethical and political ramifications if they're trying to do some kind of task out in the And so there was most certainly criticism of these errors, and very publicly. These kind of pictures were all over social media. So the cycle is starting. And then a little bit more slowly, academic criticism started to be published, targeting not just this one benchmark, but AI benchmarks in general as a methodology. And I'm going to quote from the first paper listed here. Institutionalization of benchmarks influences the behavior of both researchers and end users. Because advancement on established benchmarks is viewed as an indicator of progress, researchers are encouraged to make design choices that maximize performance on benchmarks, as this increases the legitimacy of their work. Institutionalization signals to industry adopters that models can be expected to perform in the real world as they do on the benchmark datasets. So close alignment of benchmark datasets with real-world tasks is critical to accurate measurement of collective scientific progress and to safe, ethical, and effective deployment of models in the wild. And this close alignment that would need to be there for safe, ethical deployment in the real world generally doesn't really exist. And given the scale of newer data sets that now have billions of data points, not just millions, it would be very expensive to build them in such a way that they were free of these kinds of problems and closely aligned with the tasks that they're meant to represent. And there have been two kinds of response to this round of criticism. One kind of response is this type of thing, which is the kinds of things that people were saying to Timnit Gebru in this Twitter fight. My blocking out of the people's names doesn't seem to have worked very well on the screen. Sorry about that. So people saying like people in social science don't know what they're talking about, kind of like a get off my lawn kind of response. Very hostile, maybe racist in the first case, sort of responses. And Gebru is a computer scientist actually, so like it's not even really accurately directed. And I think this is sort of midway through the first controversy. And I think she clearly identifies one issue that's going on here of who has the authority to offer critique. So it has to be insiders, people in our own community, or it's not going to be heard. So you can bring in people to experts from outside to your own house. Doesn't matter, nobody listens. So not only does it have to be insiders, but to be heard, but it seems like the act of critiquing too harshly or reading too widely outside of AI can kind of get you kicked off the home team. Like Gebru, who is a computer scientist, not being considered an authority who's allowed to critique AI. Fun fact, AI has a particularly narrow view of who belongs to the field and what kinds of expertise are deemed relevant and what kinds of problems are deemed interesting compared to other branches of science. And there's sociological studies of the field, starting with one in the 90s by Diana Forsyth called Engineering Knowledge, the Construction of Knowledge and Artificial Intelligence. That's sort of one of the first studies noticing this. More recent studies say kind of the same thing. Although Forsyth is a sociologist, so what does she know? Another kind of response was to these sort of embarrassing gaffes and the criticism that they drew was to investigate the problem further, see what's happening, and see what we could learn from the problem. So like advancing the science. So here, the images that were getting misclassified in these sort of embarrassing ways were dubbed adversarial examples in this paper from 2015. And this paper showed that deep neural networks can be tricked into giving kind of wildly incorrect answers on object recognition tasks by perturbing the image so slightly that a human doesn't even notice the difference. So here, this noise image, or what looks like noise, but that is selected to sort of shift the image from panda to gibbon, is added at sort of 0.007 strength to the original image. You get the second image that looks the same to us because the changes are too small to be renderable as pixels. So you're actually looking at the same image. But here, the deep neural network calls it a gibbon rather than a panda. And there are lots of other examples like this. So it seems like deep neural networks are, if they're doing object recognition and images, there's something seriously weird about the way that they're doing it if they're able to make these very strange shifts of their perception of what's in the image. And then other kinds of examples followed. So deep neural networks are detecting objects like penguins and starfish and bagels and race cars and images like these that look like meaningless wavy lines to us, or images that look like just noise. And a kind of a cottage industry emerged where people were tricking AI in new and kind of more ridiculous ways. And ways that were maybe deemed possible security or danger risks in the case of the stop sign being seen as a speed limit 45 sign. But humans are subject to mistaken visual judgments too, of course. Like we're tempted to see this garbage bin is floating in the air because it happens to be behind a dirty patch on the sidewalk about the right size to be its shadow. And we see a triangle popping out that is non-existent because of the cleverly arranged Pac-Man shapes around it. So maybe there's something unfair about making fun of AI for also being subject to something like optical illusions. So people started to investigate this, and one example was Firestone's lab. He argued that investigating these adversarial examples, we should be sure to make fair comparisons, the same way that we would in cross-species comparisons of cognitive abilities or with humans of different ages. So we propose that we should place human-like constraints on machines and place machine-like constraints on humans when we're making these comparisons. That seems fair. So here's an example where human-like constraints are being imposed on machine performance. So if you remember the panda given case, the changes were too small to be renderable as pixels. In this study, the deep neural network was constrained to first pass the high resolution image through sort of like a filter modeled after the human retina, and then use the result of that as its input. So basically, it got a blurrier image to start with because we have a blurrier image to start with too. And if you then construct adversarial examples that work on that system, you end up with much less subtle changes having to be made for it to change its classification. You end up with something like this, where a cat is being perturbed to look like a dog. But when humans look at this image, we also are tempted to say that the one on the right looks like a dog. So if it's constrained to have a visual system more like ours, and then you construct these examples that will trick it, we're tricked too. So it's not doing something so weird. Maybe deep neural networks just sort of like have better eyes than we do, and so they can detect more subtle changes. And then here's an experiment that goes the other way around, where you're putting machine-like constraints on the humans. If you look at these, what would you say is in these images? Answers?
Nothing at all.
Nothing, noise. Yeah. But if I ask the question in a slightly different way, the way that the machines are actually asked it, you might be able to do better at this. So the way that this is asked of the machine is more like, given these 5 images of a robin, which of these 3 noise images looks most like a robin?
Yeah, one on the right.
On the right. I think so too. Yeah, so suddenly we're finding that there is some kind of like cognitively relevant information in these noise images if we're asked the question in a different way. And humans can pick these out reasonably well too. So it suggests that what deep neural networks were doing when they're picking up on something in these images might be some kind of cognitively meaningful signal. So maybe these kinds of adversarial examples are not it doing something like just totally mysterious, but maybe it's doing something that's like actually kind of smart, and that's sort of like what we do, just being asked a different question. And here's another example from Firestone's lab. So if I ask for your first choice for what these images are, you probably say something like car and turtle. But if I ask you for like, well, what's your second choice for what these are? If you can't say car and turtle, then you might start to pick up on how there's kind of like a snake texture on the bottom of the car, and how there's like a jigsaw puzzle texture on the turtle. And the way that, that the AI does this task is by ranking its top 5 choices of label. And if you ask humans, like, what's your second choice of label after you've already given your first choice of label, those second choices of label match up with the AI's answers at better chance levels. So these are the labels that the AI gives them. So one interesting finding that came out of this is that deep neural networks tend to be more sensitive and biased towards texture cues rather than shape cues compared to humans. And that was discovered, because of these adversarial examples where I was giving like the wrong answer. And while it's not typical of humans to prioritize texture over shape, Texture ends up being like a perfectly good set of visual cues to use for doing object recognition too. It's just not the way that we do it typically. So it's sort of like a weird fact that we found out about humans, that like given these two sort of choices of how to solve this problem, like we happen to choose one of them, the AI happens to choose the other one. But if you then bias the AI towards not using texture by giving it examples where the texture is misleading and the shape is necessary for disambiguating choices, then it will start behaving more like us. So again, the deep neural networks, like anomalous seeming behavior, predicted a bunch of interesting things about both machine vision and human vision. Like we learned a bunch of things from investigating these things that were at first embarrassing problems. And so we get what looks like a progressive research program. So the upshot is defending broken benchmarks because the people pointing at the problems have read some social science is probably not the right way to go. And sloppily designed data sets should probably never have been called benchmarks in the first place. This doesn't mean that those data sets aren't useful. They've been incredibly useful. They're just not useful as standards. They're not something like solid and objective and unchanging the way a benchmark is supposed to be. So in the case of adversarial examples, anomalous results, problems led to interesting new discoveries when the criticism was sort of taken up as a clue to do more science. And so if we treat these sort of so-called benchmarks more like moving targets that need to be continually updated and improved, that are subject to criticism and where we're going to respond to the criticism, will fare much better. So when people in AI complain that critics are trying to move the goalposts every time a new sort of benchmark is passed, that's not interference in the practice of science by confused outsiders. That's moving the goalposts, or in Lakatosh's words, turning counter instances into corroborating instances, is exactly what we need to be doing if AI is going to be a progressive rather than a degenerating research program. And curiously, the oldest test in AI, the Turing test, is not a benchmark at all. It's a moving goalpost. And maybe that's the reason why it's remained sort of strangely relevant over so many years. Judges of the Turing test can kind of like get wise to what AI is doing, ask different kinds of questions as the science develops. And asking these trickier questions, continuing to be critical, isn't being unfair or anti-science. This is just what progressive science looks like.
Thank you very much.
Something screen sharing.
Oh, looks like you're doing it. Okay, great, perfect. Well, thank you, Catherine. Oh, looks like you're doing it. Okay, great, perfect. Well, thank you, Catherine. We're pleased to now move into our discussion period and welcome questions from all participants. Just as a reminder, for participants in the room, just raise your hand. And you don't need a mic. And then for participants online, just type your questions in the chat and we have somebody moderating who can ask them. I'll just open it up right now. We start with Steve.
Sure. So thanks so much for like a really useful example-rich talk. I think my question's just I think asking your opinion about something further in the talk. So, what would you say your view about the relationship between that process of internal criticism is and benchmarks themselves? Like, does criticism of, say, AI development always proceed in terms of benchmarks? Is the problem that is that a problem that it's kind of always cashed out in terms of benchmarks? I guess one way of kind of restating my point is I sort of thought where the talk was headed was outright criticism of benchmarks altogether, and I guess the conclusion that you ultimately drew was more that benchmarks are okay, but that it's just important to apply the same kind of practice of internal criticism to the benchmarks as well as AI development. So I guess I just wanted to get more from you about what you think about the relationship between the process of internal criticism and benchmarks as a whole.
So I guess if the only thing going on in AI as sort of as a science rather than as engineering or product development. Just to make things clear, were this kind of like benchmark chasing, then that would be a problem methodologically, I think. But that isn't the only thing going on in AI. There are lots of other ways of evaluating progress that people use in addition to that. So I think the problem is more of confusing benchmarks for something that they aren't. Confusing them for some kind of like established test that like now we've got this task down. And that's probably never going to be true unless the task that you've got down is very narrowly defined. So slippage between what you're actually achieving and what you're kind of pretending that you're achieving, that's more I think the valid criticism of benchmarks, but that doesn't mean that there isn't a place for them or like useful ways of.
Yes, sorry, I don't know your name. Go ahead.
Very great talk. I really enjoyed it. I'm curious your thoughts on what role industry plays in this relationship. I guess I completely agree with a lot of your points around how we can very much get ourselves into another AI winter if we aren't embracing criticism. But I feel as though industry is playing an outsized role in the research, and in our move fast and break things Silicon Valley ethos, criticism, there's not really a place for criticism. So I'm curious if do you see an AI winter coming less because of researchers not embracing criticism, but perhaps because industry just won't allow a different approach to AI or bring that criticism in a healthy way? I'm biased. I come from industry, so I have my own thoughts, but I'm curious your thoughts on it.
Yeah, I think this is a complicated question, and I don't know if I have a simple answer to it. So yeah, I mean, there's definitely a bunch of research coming out, and including from my lab, about the influence of industry on AI, and one of those influences is that if you're in industry, you can kind of like do better on these benchmark tasks because you have more compute power available, staff available to help you, more money to run more experiments and so on. And so there are advantages to all of that in terms of competing on the benchmarks. And if we're overly focused on benchmark results as markers of success in AI, then that's going to benefit researchers in industry. And we also know that the people who are paying you have an influence on the kind of research you do. That's well established for humans in general. So yeah, there are reasons for worrying that industry desires and sort of incentives are going to be kind of coloring the kind of research that we're doing. So that I think is pretty well established and like a genuine worry. Whether this attitude towards criticism comes from industry or comes from the sort of culture of computing, like I think there's maybe multiple areas that's coming from. So I'm not sure that industry is to blame for that or exclusively to blame for that, but yeah, I mean, the reason for the hype cycles in the first place is because you're going to get more funding and more money if you hype what you're doing. So there are business reasons for focusing on the positive and pushing away negative.
Let's go to the chat and take this question from, I think it's Gian. Oh, okay. When do you want to go to first, Rachel? Do you want to start? Yeah, because I think this one actually was going to say builds on what this last question a little bit. Gian, did you want to unmute to ask your question? Would you like us to read that out? Okay, I'll go ahead and read it then.
Sorry, I couldn't unmute myself. I had to be given permission to unmute. So thank you, Catherine, for your wonderful talk. So I suppose my question is actually a kind of follow-up to the previous question. So my question is essentially this. A lot of critiques of AI center around data. So there's essentially this sense that if only we had the right types of data and the best data, then all of our AI models would work perfectly well. And so critiques of data are essentially biases within the data that exist. However, benchmarks actually affect yet another point of criticism, which is the design of models themselves, which somehow AI developers have tried to make themselves immune from that particular criticism that, well, we should kind of take for granted that our current model design approaches are very good. The problem is, and this is where my question comes, AI academia largely depends on industry for making progress nowadays. Those things are inextricably linked, and we can kind of see that in the Canadian AI politics themselves. So is there some way that we could potentially reconcile this? Because I think your talk kind of hits upon this core issue. Thanks.
Yeah, I'm not sure how these two things are connected. So I mean, I've, in print definitely said that the sort of data is the problem approach is wrong, and that the model design also can introduce bias and matters. So, but I'm not sure how that's connected with industry issues. Can you say more about that? But why is it that industry being involved makes
Yeah. It's largely because a lot of the model design approaches that have become innovative and are novel in recent years comes from the advances that are being made in industry. And actually, most of the kind of really exciting breakthroughs have been collaborative work done by academics who are kind of embedded in industry. And so the issue around this kind of general critique around benchmarking, that is which models perform better or worse on what types of datasets and why and how is largely it's a main issue because certain types of disagreements that arise out of which benchmarks are useful and which benchmarks should we be using come from this kind of political kind of influence that industry has on what benchmarks exist. So I mean, obviously, I'm not asking you for a solution per se, but I was wondering if you kind of thought about this general idea of the relationship between academia and industry around benchmarking itself.
I think you're right about how, like, the sort of amounts of investment that people have put into design and also data set building end up, making people sort of worried that they're going to become irrelevant if there's criticism of either of those things. I don't know if it's easier to make a new data set than to make a new model. So maybe both things are worries. But yeah, whichever way that goes, there's probably something happening where the methodologically we're getting kind of like streamlined and there's less freedom to be kind of creative and develop new methods because there's so much money on the line.
We had a question in the room. Do you want to go ahead?
Yeah, thanks for the talk. I think that this is a really great argument. Like it's very simple and effective. I think it does a great job. I'm also thinking that it sounds to me like what might be the concern as you're presenting it is that the criticism leads to that kind of loss of investment money, right? Like that's sort of the idea, is that people are like, oh, this is not going to work. Like all of these issues with AI are coming out. So now I want to pull out of funding. And I was thinking that this kind of seems like an issue with science in general. Like especially right now with the NIH in the US, the sort of standard argument is like, why are we funding billions of dollars and cancer still hasn't been cured, kind of thing, right? And if you just asked a scientist, they would say, well, this is the process of research. You know, you have to have this criticism, you have to have this back and forth, et cetera. So I guess I'm wondering if you see that similarity and whether or not an argument like this for the value of criticism and like thoughtful movement in AI research would be convincing to investors, or like, does this solve that problem?
I guess right now, this problem doesn't feel very solvable, like, or at least I don't feel very like I have much power in trying to address this sort of bigger problem of the funding of science, and things are going in, you know, directions where this kind of thing is gonna get worse. But like another thing that, other than, you know, criticism being necessary for science, another thing that is necessary for science is that there are some risk takers in the scientific community. You know, not everybody needs to be a risk taker. Some people need to sort of, you know, do the things that seem the most promising, but the sort of research suggests that we need some people who are trying weird things that, you know, don't seem like the most likely to work out, because sometimes they will. So we need kind of like a broad base of what kind of approaches are being attempted in order to discover new things and make progress. And with a more, you know, government funding of science kind of model, those risk takers like have a chance to get funded, and probably in industry there's less chance of funding those risk takers. Like 20 years ago, Google was doing more risk taking, and so it was a little bit different, but now it seems like if you're in industry, you know, obviously you need to be doing something that's of benefit to the company. And so this whole narrative about how, you know, you need to show the you know, the impacts after 5 years if you're going to get a grant, there's something kind of wrong about that in the first place, given, you know, what we know about what makes for a healthy scientific community. And I don't think that answered your question, but it circled around it at least.
Why don't we take a question from the chat from Jason here? Jason, would you be able to unmute?
Sure. You should be able to hear me okay. I guess my sort of central question comes down, you did a fantastic job of identifying a problem, right? A need for informed skepticism around R-squared hacking, i.e. benchmarks within the ML community. How do we action that? How do we create that community in a robust way? I was really looking for a solution because it's a problem that my own field has.
I mean, I guess one talk at a time is sort of my approach, apparently. Just try to convince small groups of people like this that the field should have a different attitude towards criticism, and a sort of more open attitude towards whose voices are relevant, and, you know, who should be considered as belonging to the community. How to achieve that in terms of cultural change, you'd have to ask a social scientist. Question.
Thank you. Other questions in the room? Or we'll move to another one in the chat. Sure, I'm not missing hands. Okay, we have a hand up from Ara.
Hello, can you hear me? Hello.
Yes.
Perfect. Yeah, thank you. So I think it's related with the two previous questions, and one is like, I totally agree with what you said and your criticisms for benchmarks, but isn't it unfair to make this point with respect to AI specifically, when probably most of the points you raised can apply to neuroscience in general? Just like, of course you are using the term benchmark task because that's what we know about AI, or it's a term that usually is related to AI, right? But for example, I don't know, there are many examples, but in neurophysiology, or like there are these papers coming out saying that some type of animal or some species has consciousness or reasoning or causal reasoning. And of course, it applies all you said about the funding and about publishing and having like this in the title of your paper. But I think it's more about exactly like the dynamics of science, the sociology of science, and how we manage that than about AI itself. Or could you say in which sense this is a problem specifically for for AI? So that part I felt it was a little at least unclear to me. And the second, is like what could be the alternative in the field of AI if benchmark tasks are not like are problematic in that sense? Because my impression is that, or the opposite, honestly, I believe that this type of a specific task help scientists or help the AI people to kind of define what they are looking for and open these discussions, right? Some of them said, oh, I did this type of logic inference or whatever, and the other one comes and tells you, no, you didn't good enough, or this is not what you are talking about. Even philosophers now come and have something to say, and at least we know we are talking about this specific task of specific examples of performance. While if you don't have this task, I think it could be even worse, right? People just could say whatever they want with respect to a very different task or a very different paradigm that they are using. So I don't know.
Thank you. On the first point, so yeah, I think there are other people who've made more general criticisms of the sort of competition-based model of science and pointed out problems with that, and that would apply more generally, certainly. And benchmarks are used more widely in science outside of AI. About other sciences, probably too, but that's really not the thing that I can speak to. What makes this specific to AI is that there's a particular focus on state-of-the-art results in terms of how you can get a publication in a top journal, how you can get a paper into a top conference. And there's been some work on showing that that's the case, that the conferences and journals are very focused on these types of papers and these types of results, and it's very hard to publish something that is a different type of paper. So that's one place where like people have made various suggestions in some of the papers that I listed on the paper of the academic criticism for how to change this and what to do instead. So I mean, changing your reviewing practices to remind people that there are other kinds of valuable contributions, that's one of those suggestions. And just the question. So I was trying to remember the first part.
She can come back in the chat if you want to follow up with the second question. I'm going to use my chair privileges and insert myself here. So I was having like a similar thought where I'm like, what is it about AI that makes it so focused on benchmarks in particular? Like why? And also that language around benchmarks. Because like in biology, we have these grand challenges, right? So it's like other sciences have like focuses on like niche accomplishments that will get widespread praise. But AI seems to be like really around benchmarks. And I do think like I just wonder like if you have like a thought about that. And then also like my kind of like initial suggestion, which maybe you can like speak to, is about like the way AI started around the Dartmouth College paper, where the authors say like, we'll define AI as whatever a human could do. If a human could do it and we would call it intelligent, then if an AI does it, we'll call that intelligent. So then from that came all these things of like, well, humans can spot objects, humans can drive cars, humans can play chess, humans can X. And those all became like their own sort of benchmarks for what we want the AI to do. But I don't know if that's like, I mean, that's just kind of like a gut feeling about that, but I'm curious, if you have any thoughts on that.
One positive thing about the sort of competition model of doing science is that it gives sort of like up and comers an opportunity to kind of like break out and make a name for themselves. And I think there's something appealing to people about having that kind of opportunity. It's exciting and it seems meritocratic, which people like.
Yeah.
So there are positive things about it. Whether it's genuinely meritocratic or whether you have to be in one of the top 5 labs for that to actually happen for you is another question. But I mean, there there's obvious reasons why people find it appealing. Second half of the question.
No, it's okay. We'll go to the chat and then I'll exercise more chair privileges perhaps. So this is Safia, and would you like to unmute? Give a second because I know it takes a minute. It's for Safia.
Yeah, hi.
Go ahead, we hear you.
Yeah, can you hear me? Okay, thank you. That was a very nice talk. I really enjoyed it. So my question is more from the philosophical, sociological side of things. You've talked about AI criticism, but the majority of AI criticism, at least in the public sphere, it actually comes about AI overperforming, actually potentially replacing humans because of its efficiency, because of its precision, all of that. And most of it is coming from the big names in AI. So it's as if they're completely ignoring, the big gaps in benchmarks, as you've talked about. And also, the other issues related to AI underperforming. So what are your thoughts on that? Thank you.
That's another complicated question. Yeah, so there is this definite trend where the sort of bigger names in AI, when they're talking about criticism of AI, focus on these sort of safety questions and whether humans are going to be wiped out by super intelligent AI. And it's I think kind of an interesting sociological question where that comes from. One kind of answer that I've heard for that is science fiction. Another kind of answer that I think fits with what I've been talking about is that it seems like the big names in AI don't read the kind of criticism that I've been mentioning. So they don't read the criticism of benchmarks. And one reason I have for thinking that is that in a discussion with someone who was a big name in AI in a reading group once, I offhandedly mentioned something about criticism of benchmarks, and the response was to assume that what I meant was that empirical tests were somehow wrong, that I was against that, that I'm against sort of using any kind of objective measures of performance, which is not, what the criticism is at all. It was just like a complete lack of understanding of what I was even talking about. And so like I think people just are completely unaware of this, and maybe that comes from just, tuning out any voices that seem to not AI flavored. And that's the sort of like narrowness of, which voices are considered, the relevant ones to listen to. So that's my guess. And I have other opinions on that I'm not going to air publicly.
Well, I'll exercise another question that I had around that, which is like, I don't, not to put pressure on that, but like, I wonder if there are, like, clearly there are other scientific fields where there's people who assert that they have the epistemic authority or that they are the authority, and that there's other people who are not. And I guess I'm wondering, like, what you think that maps onto in the case of AI, or sort of, I don't know if that dynamic seems like that it basically like is an example of a dynamic that we're seeing in many other sciences, or do you think there's a unique AI flavor to that dynamic? And I think either of those might be like plausible. I don't really have like a horse in that race. I'm just curious how you see it.
Yeah, I mean, the other kind of answer is like follow the money.
Yeah.
And I'm not sure what exactly the whole story there is. Like, I don't know why it is that the money seems to be following safety rather than other problems.
Mm-hmm.
But that seems to be like a very definite trend that the people with like a lot of money in the game want the focus to be on AI safety. Yeah, like that seems clear, and like why I don't know.
Yeah, do you have a question?
Yeah, that was a great talk. Thank you so much. I guess I'm always curious how other kind of philosophers working in this area kind of handle like wanting to encourage people who are working kind of, let's say, more on the tech side of the AI space to like listen to the disciplines that they really want to dismiss, such as like research coming from critical social sciences, from philosophy from ethics, because that seems to sort of be a trend. And I think there's a certain amount of like productive discussion that comes from like, philosophers and social scientists talking about these kinds of topics and issues in their own / our own kind of circles. But like, how do we make joining those conversations enticing for the people who are maybe trying to reach more broadly?
I guess what I'm doing here is sort of advertising, like, you should listen to people like me. I want it to be relevant. I've got something to say. So there's an element of that to what I'm doing, but what I'm trying to say is on the line is like, if you don't want the AI winter to come, if you don't want to lose the cash cow that you're riding right now, here's a suggestion for something that might help. And that's one way of getting people to care. That's kind of the strategy, I guess.
Another question over here, yes.
Yeah, I just wanted to go back to the point on safety and why a lot of them are focused on safety, just a perspective from the private sector. If you care about your brand and you're using AI, you're going to want to focus on safety, right? So I think that that's probably why there's a lot of money circulating around.
It kind of depends, like the words are used in funny ways. Like safety sounds important, but fairness sounds important too.
Yeah.
And why isn't fairness something that people care about as much? Or like ethics should matter to your brand.
I think from a consumer perspective, if you're focused on the consumer, and I'm not saying that I hold that view, but from like a private sector perspective, I think thinking about your brand and sort of conveying that as the consumer using this piece of AI that's attached to my name as an organization, I want you to feel safe using it. So that would be my theory on it.
So then a strategy might be call your work say that it's about AI safety regardless of what you're actually doing.
Yeah.
We'll take a question from the chat from, I'm not sure if it's Ali or Ali. And I'm not sure if you'd like to unmute or not.
Yeah, sure. Thanks, it's Ali. Yeah, thanks a lot. So, yeah, I think, maybe I just switched the gear a bit. So I just focus more on the concept of machine learning rather than the general concept of AI based on the most example you gave today. So first of all, thanks for the great talk. Sorry, I forgot to mention that. And when it comes to the machine learning idea, so usually, the most important thing for us is about generalization. The concept that we are just looking limited, but we have limited experiences, but we want to talk general. Then usually, in the area of, say, computing AI, benchmarks are mostly the things which are somehow we are a bit more confident about them, that they are going to help us achieving this generalization more robust or in a form that we are not in the illusion of generalizing simply. So if we just get out of this benchmarking and then we get into the real world data. So this could have always this concern that we are actually assuming that we are generalizing because we are focused so much on that kind of data that we have. But then at the very end of the day, we are not really doing that. So it's this benchmarking to many of us is basically like a kind of federal regulations that we need in order to somehow make sure that we are not actually saying somehow nonsense at the end of the day. So it's true that this is going to bring a lot of critics from the other people, but wouldn't that be at the very end of the day more harmful? Because if we take those critics and somehow move in their direction, we do already know that it could end up with doing even worse. I mean, we just give promises, but at the end of the day, we cannot do it because we know those real world data are not going to help us in that direction. And at the end of the day, we come back to them, making them more disappointed, and then we can even have worse kind of winter at the very end of the day. So I would really appreciate your comments on that. Thanks.
Generalization can mean lots of different things. So it can mean, that you're doing well on the 20% of your test set that is held out from the entirety of the data based on training on the training set. It can mean that this task that you've learned your model on is representative of the task in the real world. It can mean that once you've trained a model on this particular task, it's then also good at other tasks that are related. So there are lots of aspects to this. And benchmarks, what's appealing about them is that you get something that seems like that's measurable. You can measure the generalization in this kind of context, but it's harder to measure some of those other kinds of generalization that are also important. So like having your progress be measurable so that you can compare your model to another model, like that's a good thing. That's a desirable thing, because you want to, know which models are doing best. You want to know which avenues are sort of the most productive to go down. But confusing that with broader kinds of generalization, I think is more the issue. If you think that because you had a slightly better result on a benchmark, that means that your model generalizes, well, you need to be more specific about what you mean by that. It doesn't mean that it's necessarily going to work best in the real world. And sure, there are dangers to using real world data that's messier, and it can be harder to just figure out how to do well when your data is messier. But at some point you need to deal with that problem if you're going to make something that's going to be deployed.
Yeah, great. Do I see some hands here? Emily?
Thank you for your talk. I really liked when you brought up the question of and I was wondering, with your background in policy, my first question is, what responsibility do you think programmers should have to address the public concern? And the other question is, what are the actions that the general public can take to make sure that they are kept?
Yeah, those are tough questions too. So programmers should have some kind of awareness of how what they're making is going to be used, but of course their view on that is necessarily limited, or you're given like a very small chunk of a larger project generally, and so it can be kind of impossible to know the full scope of and what the impacts are going to be. So you're in a kind of a tough position to be able to do that, and also given the way that computer science education works, people with computer science degrees don't have a lot of experience with anything outside of very kind of programming focused topics. And I say this as someone who sort of teaches the social, ethical, and legal issues in computing course at Queen's. And so I see the students in the one course that has kind of a broader scope than everything else in the curriculum. And so it's not at all surprising that that's kind of like an impossible situation that you're put in as a programmer. The one thing that I'd say is that trying to pretend that your job is purely technical, like that's not really a viable route, because your job is not purely technical, even if the skills that you have are mostly technical, and if the particular things that you're asked to do are technical, no job is purely technical. So having like an interest or an openness to the impact of what you're doing is one thing that I would hope for. And the general public, I think, is also in kind of a bind, because literacy in computing topics is not particularly good among the general public. And part of that is because I think there's a tendency of people in computer science to want what they're doing to seem mysterious to the rest of the world, and to want it to seem, harder than what anyone else can possibly understand or achieve. So that, because that's, feels good for people in computer science to call themselves the most brilliant people on the planet. And that's another kind of like funny sociological phenomenon in computer science that in sort of advertising and promotions for AI related events, claims will be made about like the most brilliant minds in the room and the best minds in the world are going to be here. And I tried searching for those sort of terms like brilliant minds, best minds, plus like other fields. And you don't find those kinds of claims in other fields. Mathematicians don't advertise their events that way. Philosophers don't do that. Nobody else does that. Just sort of AI and tech related, like make those claims about themselves. And having done AI and philosophy, like I know that it's not harder than the other things that I've tried to do in my life. It's just more finicky. So yeah, I mean the general public is sort of probably could have better literacy if there wasn't this sort of like cloud of mystery around AI. I think it is sort of achievable knowledge for people, but it's hard to find. So yeah, I mean the responsibility that the public has to be tempered by the amount of information that they're given.
Philosophers should be more bombastic.
You know about that.
Yeah, I don't know. Maybe that's not the lesson to draw.
Well, I'm 100% not a philosopher of science, so I don't know if this distinction really makes sense, but I could imagine, like, so I'm an ethicist, and so I'm used to thinking of a distinction between like ideal theory and non-ideal theory. And I wonder if there's like something similar that you might say about inquiry, that there's like an ideal way of conducting an inquiry in some domain, and then like various like ways of diluting that so that it's like a non-ideal way of conducting an inquiry. And I wonder, if that distinction makes any sense at all, like, are benchmarks like a feature of, like, are you only going to find benchmark in that non-ideal kind of way of doing inquiry, or would idealized inquiry also feature benchmarks? I mean, whether we're talking in general or about AI in particular.
I was gonna say that there's a place for benchmarks, and the only issue is that they've been overemphasized. Maybe they're part of the ideal.
Did you have a question? Yeah.
I think there are a lot of parallels between benchmarking and measurement. In a way, like benchmarking a model is kind of like measuring not maybe at a specific quantity like heat or a temperature, but you're measuring kind of its intelligence or functional capability. I'm wondering how far does this analogy go? So for instance, you might consider benchmarking like really primitive measurement devices. So, and if you go back to the early history, let's say thermometry, you often had trouble adjudicating between which thermometer is better because you don't have a good thermometer to measure by which to compare with the other thermometers. So you have this kind of problem in philosophy. It's been called the problem of gnomic measurement. And I wonder how it applies to maybe benchmarking. The usual solution is that you have this kind of back and forth between the measurement devices and the theory, but it's hard to say that there's a theory of intelligence, of functional capability in the case of benchmarking. So how can you resolve these issues? In thermometry, for instance, you could resolve it by considering heat as a theoretical quantity of work, as Lord Kelvin did at one point, but I don't see such a solution available for benchmarking.
Yeah, I mean, the danger with benchmarking is that the thing that you're measuring is not really the right thing to be measuring, or that it's your measure is not like a valid measure of the thing that you're trying to get at. And so you can have as sort of precise a measurement as you want of something that's not relevant to what you're trying to get at, and you can do the best at that benchmark that doesn't matter, and that's sort of the danger here, that you're constructing these benchmarks that are not really about the thing in the world that you're trying to make them about. And I was involved in building like a big benchmark for large language models, and I know that what I was doing was not careful science. It was like pretty haphazard, but it was, by some reasonable measures, one of the most successful tasks in this benchmark. So like, I don't think I was doing it in a worse way than other people were. like Googling stuff and making jokes and yeah.
Let's take a question from the chat and then we'll move to one in the room. Thank you. Harshit, did you want to unmute to ask your question? Are you able to do that?
Hi, I hope you can hear me.
Yes.
So I wanted to ask, seeing the reliance that we're having on AI compared to 2 years ago when we didn't even really care about it, where do you see our future in it? Like it's being involved in each and every aspect of our lives, going from talk about statistics to app development to all kinds of things, creative or non-creative. Do you think that there's a limit or like anything where AI won't be able to be there for us? And if so, where?
I think that's kind of the billion-dollar question right now. I mean, I was working in this field before it existed. I was told to take philosophy of computing off my CV because it's not a real area, 10 years ago, and now it's the only thing that you can get a job in philosophy. So maybe I predicted really well just with bad timing. Yeah, I mean, there are people expecting the bubble to burst anytime now, and there are other people saying like you are that it's going to be in everything and it's going to be everywhere, and it's just the way life is from now on. Either of those could be true at this point. I think it's kind of hard to say, and I don't lean a little bit towards the bubble is probably going to burst side. Mainly because I think we haven't really been accounting for the cost of putting AI in everything. It's being funded by like venture capital right now, and we're not seeing the real price tag. But I think when we do see the real price tag, it's at best up in the air whether it's going to turn out to be cheaper than having humans do this labor. So maybe we're not going to have AI and everything after all, because it's actually not going to be more efficient than human labor.
We have a question in the room.
Yeah, back to measurement. I remember from my undergrad lab reports, the thing that we had to be careful, source of error, calibration of device. So thinking about AI, and I still don't know much detail about last week in France about AI conference, but I've heard from reporter that different countries are approaching in different ways to AI. So now I'm kind of checking, okay, if this is gonna be a tool for us, we should have a criteria for source of error, uncertainty, and kind of calibration. But specifically because, Chinese word different from the West, as far as I know. I've been here in the West until 2015, and then I moved to China teaching there. And I know exactly that word is different. Definitely AI is different. One of my students working there on AI, and he comes and goes to Las Vegas to get market. So how we can approach this problem? Calibration, source of error, uncertainty, those basic that we did in undergrad.
So if your undergrad is in psychology or biology or in anything else in science, basically you're going to take some methodology courses, you're going to take some research methods courses, you're going to learn some sort of statistics applied to the particular kind of research you're going to be doing. And that kind of course doesn't really exist in computer science and AI. And so people don't know what they're doing methodologically. They don't know why they're doing the things that they're doing. And there is some, reason for using the methods that we're using, but people thinking kind of carefully about is this the right method for this job? Is this an appropriate method in the first place? There's a lot less of that happening in other areas of science. And I think that's an issue.
Are there any further questions? Oh, sorry. Go ahead, Alex.
Yeah, I was really struck by the panda gibbon example, and I'm curious, like, was that a totally contrived example, or is it based on something that could happen just like that in real trials? And then more broadly, the implications of if they're the kinds of problems that we have no idea could exist until we see them. I guess, why doesn't that maybe strike more fear into people if they want to use their models in the real world and they see these examples that they couldn't have expected? Why do you think the instinct might just be to cover it up when there could be such like disastrous results for that? I know that's more of a social question.
I think the application to self-driving cars, like people were worried about some of these examples and the kinds of, you know, mistakes that you can make thinking that you know, a bicycle is just the road ahead of you. And so there was some worry about it. There is some worry about it. As far as I know, the panda gibbon example is totally contrived. It's not, you know, based on, I don't know, zoo bots being confused about which animal is which. I don't think it's that.
Like, my sense is like the adversarial attack had its moment and now it doesn't get discussed as much. Is that your sense as well?
Yeah.
Yeah, okay. Oh, yeah.
And yet, adversarial methods have taken off, and like that's one of the main methods that's being used in lots of areas. So like the methodology behind that has taken off.
Yeah.
Whereas those particular kinds of examples with images that's kind of died out.
Now it's like adopted as a red teaming or something.
Yeah.
Thank you so much, Catherine. Any final questions here? Oh, okay. Yes, Buyan.
Thanks for your talk. Most of the cases mentioned in your presentation was related to vision. I want to know, could it be applied to language model as well? And especially because in language model, we have benchmarking that people also participate in, like SAT or solving difficult mathematical problem. So in that case, when is like human benchmarking and machine benchmarking collide, is there any difference in that domain?
I think the same kind of issues crop up. Like there are also embarrassing mistakes being made by language models. I just don't happen to know like a good case study there that fits this narrative, but probably they're out there. I can't say more.
All right. Thank you very much, Catherine, and please everyone join me in thanking Catherine as well. For those in the room, we invite you to stick around to enjoy some of the refreshments we have outside. I'd also just like to thank the Schwartz-Reisman Institute and the Institute for the History and Philosophy of Science for together collaborating on this seminar and co-sponsoring it. I also want to flag our next in-person collaborative seminar is going to be on March 19th, which will feature the University of Guelph's Joshua August Skorberg. And event details and registration are already available on SRI and IHPST websites. In the meantime, please join the SRI Institute for the next SRI seminar series, which will be on Wednesday, February 26th, as we welcome Yi-Jin Choi, Professor of Computer Science at Stanford University. And details for that are also available on the SRI website. We look forward to seeing you then. Thank you.